Today I'm going to talk about the logic gates for NEET 2024. In the syllabus, they have mentioned only 5 logic gates: NOT, OR, and NOR. So these are different types of logic gates. So we can start with. So first of all, what is a logic gate? Consider that there is something called as uh, in digital systems. What we do is there is a binary number system is followed. So there are only in binary means base 2 number system, like decimal is base 10, but binary is base 2, that is only two numbers 0 and 1 are there. So with 0 and 1 there are numerous combinations possible based on the length. For example, in binary I can represent 0 1. I can represent 2 as 1 0, or that is not required, but I am just saying that this is based on binary numbers, either 0 or 1. You can take an example of a switch. If switch is off, you can take it as logic 0, or if switch is on, you can take it as logic 1. So this is kind of called as, this kind of logic is, this switch is known as, if the switch, for example, if the switch, there is a switch like this, if the input is 0 and if the output is 1, so that, and when input is 1 the output is 0, then this kind of switch is called a NOT gate or inverter. So this is NOT gate, nothing but if the input is 0, output will be 1, and vice versa. So similarly, this is I can write the truth table as y is equal to a bar. So these are nothing, this is Boolean algebra. Logic gates follow Boolean algebra. So if a is 0, then a bar is 1, then 0. This is a truth table for OR gate, for NOT gate. So if I this is an example. You can take bulb. In a series connection, there are n number of bulbs. So there are bulbs like this. So if there are so many bulbs, if one goes off due to some problem in the connection, then you know that all bulbs will be off. That's why we don't prefer series connection, right? You would have been studied in current electricity chapter. So this kind of connection where if one of the input is off, that is 0, you can consider that off is switch is off, 1 means switch is on. You can take an example like this. So if I take off, so if I take the input is 0, that is one bulb is off, then all bulbs will be off. But that is, take an example, this is nothing but an AND gate. This is how an AND gate works. Like there are we are only concerned with two inputs here, A and B. Take an example, A and B. So for two inputs there are 4 possible combinations: 0 0, 0 1, 1 0, 1 1. So when both the inputs are 0, output y is equal to a dot b. This is simply multiplication, you can think. So a dot b. So 0 into 0 is 0. So if both the bulbs are off, no problem. 0 into 1 is also 0. I told, right, in a series connection, if there are 2 bulbs, take an example that there are only two bulbs. So if one bulb is off, still this total connection is the second will be automatically off. So in this there is no light at all. So this is also 0. Similarly, if A is 1 and B is 0, this is 0. But if both bulbs are on, that is, then you get the light. So 1. Only for when both inputs are 1, then only the output will be 1. This gate is called as AND gate, and this is the symbol. You have to remember the symbol. This is output Y, and this is a symbol for NOT gate, and this is a Boolean expression A dot B. So similarly, if two bulbs are connected in parallel, I take it like this. Two bulbs are connected in parallel. So this is the connection. This is, let's say, input. These are two inputs, then A, B. This is output Y. So now what happens is, let us check what happens. You know that even if this bulb there is some problem in this connection, then this will be this line will be still active. That is, this bulb, if there is any problem with this line, still this line will work. So you can think that if any of the input is 1, that is, the bulb is on, then automatically the output is 1 always. So this is OR gate, and this is a truth table for OR gate. There are again two inputs for OR gate, minimum two inputs, 0, 0. Y is nothing but A plus B here. 0 plus 0 is 0, 0, 1, 1, 0, 1, 1. So these are all 4 combinations. So 0 plus 1 is 1. So you can see as 1, one input is 1. That is, if one bulb is on, then you will get the light even at the output. So it can be A or B, which is 1. And both are 1, definitely it will be on. So you can check, this is nothing but OR gate. So A, B, and this is the symbol Y. So I hope you understood these gates here. So these NAND gate and NOR gate is nothing but simply the complement of it. So I could complement is represented by bubble. If I keep the bubble here, take this as, this is OR gate. So if I keep a bubble here, then this is NOR gate, this is NOR. So wherever there is an input will be same, but output, if there is 1, it will become 0, and wherever there is 0, it will become 1. The truth table, I will write the truth table here. Let me write it 0, 0, 0, 1, 1, 1, 0, 1, 1. This is represented as A plus B whole complement. You can see that this A bar, this is for single input, but for two inputs, if you want the whatever the input, whatever the output you get for NOR gate, you complement it. That is, you pass through an inverter. You can think like that you pass through a NOT gate. So you can think that OR gate, after that there is a inverter at the, NOT gate at the output. So I can write this as 1, 0, 0, 0. Only when both inputs are 0, NOR gate output is 1. So similarly, I can right for NAND gate also. So NAND gate is nothing but an AND gate followed by inverter or not gate. So this is a symbol A, B and Y. So the truth table is A, B and Y is equal to A. Y is equal to A into B. A dot B by whole complement, whole bar. For 0, 0. So you can see that again this truth table. Here the truth table which is there, you have to reverse it. 0, wherever 0 is there, the output 1, 1, 1, 0. So this is all about logic gates. But there is a thing how to solve these questions. Now I'll take the NEET. This is NEET 2023 question from logic gates. Let me solve it. So you can see that clearly. There are, I will draw this question again. I will draw this here. Here is a NOT gate. Input is A and again a NOT gate. Input is B. Then this one is followed by an NAND gate. So what is output? What is the truth table for this? So that is what they are asking, right? The simple thing you can do is to this one you know that here after this it will become A bar after passing to NOT gate, and this one will become B bar. Now what is the thing? A bar and B bar, and then Y. What happens is that instead of A in the equation, we know that equation for this one is A dot B whole bar for AND gate, for NAND gate. So instead of A, you can think like that you can think an NAND gate like AND gate followed by an inverter for simplicity. Then what will happen? This input is A bar and this input is B bar. So this output will be A bar into dot B bar, right? So now you have to take the again whatever there is here, this will become complemented after passing through a NOT gate. So I can write this as A bar dot B bar, again whole complement. So this seems a very complicated expression. So let us, I assume that we don't know any Boolean laws. So now let us go to the options to check what are the options. So these are the options provided here. You can see that this expression, we got the expression of A bar dot B bar dot whole bar. This is we got an expression. So let me check, for example, if when both inputs are 0, what will happen? 0 complement dot 0 complement whole complement. 0 complement is nothing but 1. You know, when 0 is passed to an inverter, you can take it like this. A truth table of NOT gate, when A is 0, then output A bar is 1. So 1 dot 1 then whole bar. 1 dot 1 is nothing but 1 into 1. 1 into 1 is, you know that, right? A dot B is an AND gate. So 1 into 1 is 1. So 1 bar again, when input is 1 and then output is 0. So first, if I check for the first input combination, then I could see and eliminate the option 2 and option 4, that when both the inputs are 0, the output is 0. So the option 1 and 3 are only possible here. So now I have to check which one. So you have to check the second one, because since there is a difference in the output, if I put 0 1 here, what will happen? Let me check it. If I put 0 1, A is 0 0 complement dot 1 complement whole bar. 0 complement is when 0 is passed through NOT gate, the output is 1. When 1 is passed through NOT gate, the output is 0 whole bar. So now 1 0, take the AND gate, 1 into 0 is nothing but 0. So 0, then again if I take the complement here, that is when 0 is passed through NOT gate, I will get the output as 1. So option A, since in option 3 the output is 0, this is not correct. So option 1 is the correct answer. You don't need to check the remaining combinations. So that is how you have to solve the question. There are many other ways you can solve this. I mean that this is a mandatory step, but after this there are some other laws, and I am not going to tell that, because to memorize those things it is not required. So this knowledge is sufficient. You have to know the complement. What is the complement does? Complement is inverter. Complement is a NOT gate, right? Yeah. So this whole expression I can take it as some x. So y is some x bar. Y is equal to some x bar, where x is nothing but x is another expression, complex expression, A complement bar B complement. So you can, this is nothing but simply a NOT gate. If I take simplify the expression, so this is how you solve the circuit and get the answer. This is how you get the truth table. If they would have been asked for the output expression, then this would have been the answer. You can simplify it further, but I am not going to do it. Simplification can be done further, like you can take it as, there is something called as De Morgan's law. So using that, if I make, so this is nothing, this is equivalent to, you can check that this is equivalent to a NOR gate. So this truth table, you can check that this truth table is equivalent to NOR gate truth table. This is here. You can check this. Already you can see this, compare this truth table and this truth table, and sorry, this is not NOR gate, this is OR gate. Where is OR gate? Yeah. So this is OR gate. The truth table is of OR gate. You can compare with the truth table of OR gate. So this shows that this whole logic circuit can be simplified as just an OR gate, right? So this is very surprising, right? Because there are 3 logic gates, and again after solving you get to know that this is simply an OR gate. So why do I do this? But there are, this is an important circuit which I don't want to go in detail, but this is how we have to solve the question. Similarly, if I there's one more task you can try is, what if I replace this AND gate here, NAND gate here, by an NOR gate. Take it as NOR gate. Same question. Then what will be the answer? What will happen? You can try this, A bar and B bar. So you will get an expression for, finally after solving you will get that it is nothing but an AND gate. that can be simplified to AND gate. So this is also one example on how to solve the question related to logic gates. This is a simple, very simple topic, and we have to not miss out on this. Thank you.